So now we're going to transition to a couple of members from DAMP Lab. We'll be talking about specific parts. First will be Dave Vance, who is our bioautomation engineer. So he's out of the lab today. He's usually in there programming or fixing something lately. And we're lucky to have Dave. Dave actually is one of the ones who transitioned from the COVID lab. So he did a lot of this in the COVID lab and is now finding new uses for all these robots. Dave.
Thank you, Lynn. Well, before I jump in, I just want to say this has been really fun. It's been nice to talk to those of you that I've interacted with so far, and I hope over the next couple of days to attach myself to as many experienced automation folks as possible, and you can bring me up. I also wanted to say I appreciate people like Doug and Renee providing these sort of high-level visions of Taco Bell's, so that I can just ask the question, like, how many pieces of lettuce do you want on your taco? So that's kind of more about what this is, a little bit more zoomed in on what I think about every day and the process of automation in the DAMP lab. And a little kind of an overview of where I want to go is just very high level. This might be basic for most of you, but just an overview of automation, kind of the who, what, and why. It might not be in that order. Don't quote me on that. But those are the three questions. And then I want to talk briefly about language and sort of saying what we mean. Metrics, the scope of the DAMP work, some of the goals that I have when I sit down to write a liquid handling method, and then sort of next steps from my low-level lettuce perspective. So lab automation is a very broad topic, and I see it as kind of a spectrum. So you have things that simplify the process or a process and sort of increase the throughput. These are things like multi-channel pipettes or thermocyclers. These are things that are more flexible, more ubiquitously found, and more simple, you could say. And then on the opposite end of the spectrum, you have things that are more work cells or systems that are multiple pieces of equipment integrated together, or more complicated systems that typically have an increased capacity and more autonomy. And then in the middle, kind of the workhorse of lab automation in my mind is the deck-based liquid handling robot. Very flexible systems that can be they're in the middle kind of throughput and flexibility. And where the DAMP lab currently kind of sits is more on this side of the spectrum. And you can talk about sort of pros and cons of both, but it has been nice to have such a flexible system to be able to think about what we can do with this now. A little bit why lab automation. So this, there's so many reasons why, and then, of course, many considerations for whether to automate. But here are some benefits that I thought of. Efficiency, you have more time and space with what you're given. Data management, less time spent wrangling data or sifting through it. Throughput, more conditions per experiment or more COVID tests. Turnaround time, sort of more experiments, more questions that you can ask, and more that sample to data time is quicker. Safety is important. Something that frequently is talked about is like the overuse injuries from pipetting 1,000 times repeatedly, and then reproducibility, so you can have more confidence in a process that it'll do it the same the first time and the 100th time or the 1,000th time, which can get you in trouble too. If you've written a bad liquid handling script, it'll be bad on the 100th time too. So, always room for improvement with those, but not to point fingers at anybody. So the next is the who. So I think of the stakeholders as kind of the leadership, world's best boss, Doug and Lynn, and then sort of developers and operators. That's sort of like the team at the DAMP lab, the automation engineers, And then the customers, don't think too much about the analogy. It kind of breaks down uh, but yeah, questionable characters, but yeah, this is kind of so, and this is important because later when I talk about metrics, I think different metrics are important to different stakeholders. And there are probably more not captured here, but these are kind of the three main ones that I was thinking about. So language, one thing I was thinking about as people were speaking. So for example, with the pilot projects, I think lab automation in part is kind of a problem in translation. So Daniel Segre and his microbiome initiative have protocols, and they talk to Kristen, and there has to be a translation there that she understands what they're saying and what the protocol says. Kristen talks to me and describes what the protocols should be, and then I have to talk to a machine or a robot and say, so there's many sort of translation levels, and I think descriptive language is important in describing these protocols and also thinking about how to set up systems and processes. Talking about language, I wanted to just sort of ask this question. So what is the biggest waterfall in the world? Anyone have any? You can shout them out if you think you know.
Niagara Falls, yeah.
Okay. Victoria Falls, that they're closer actually.
Oh.
Okay, well, we got two good answers. So is it Angel Falls, Venezuela? That looks pretty big. Is it Iguazu Falls, Argentina? Well, that looks pretty big. Victoria Falls or Inga Falls in the Democratic Republic of Congo? And kind of the answer is yes. These are the highest, the widest, the largest surface area of falling water and the highest volume of water, like flow rate. So, you can talk about this with like mountains or something like, well, are you talking about the highest from, base to peak, or are you talking about the highest elevation? So I think this is a good example of thinking about like why language matters, and being, big is not a very descriptive word, or it kind of is, depends on your purpose. But in automation and in protocol representation, you can get yourself in trouble by saying, well, we just want the best thing. Another example is sort of understanding like what your criteria for success is, and sort of defining language in that way. I'm not a basketball guy, but I've sort of been following the finals, and I guess I was in the spirit of it. So if you ask the question, who's the most successful basketball player? It's like, well, what's your criteria for success? Most NBA titles, most points in a season, most career field goals, most MVP awards in NBA finals. Doug, do you know any of these answers?
Bill Russell.
Oh, nice. you don't know the rest? Okay, so pretty good. So anyway, yeah, these actually, when I was Googling this, because I'm not a basketball guy, I would have come up with totally different answers, but that's why Google is helpful. But yeah, I think with this sort of language and how we represent protocols and discuss sort of automation systems, we also need to define what our goals are and what a successful implementation would be. Moving into metrics, this was on my mind last week. I was with Pete and others at the standard or workshop for standards and metrics, but I kind of break it down in these quadrants. So you have metrics regarding the process, like the system and the protocols. Metrics, and these can be quantitative and qualitative, and I'll get into that a little bit. And then, okay, I forgot how I organized these, so I'll keep wanting to go to the other one. So yeah, examples of quantitative metrics regarding the process are things like throughput and turnaround time. What are you able to process in your system? How much can you do it? Or how much can you do and how fast can you do it? Qualitative metrics regarding the process are things like flexibility and usability. So what is it like to use your system for this process? Okay, now we can finally get to this one. Okay, the other thing is I think about the product. So this is the data or physical sample that comes through this system. And again, quantitatively, you can talk about the precision of the result or the yield or purity, whether this is very high quality, reproducible. And then qualitative are things like, well, what form does it come in? How secure is it? Are you able to easily store it and transfer it to another group or the end user? So I think there are many other examples of both each quadrant, and they're probably metrics that don't really fit into any of these or fit into all of them, but this is just one way I was thinking about looking at this. Going back to our Michael Scott, Homer Simpson, and who was the other? Walter White example. I thought, why do these metrics matter, or to whom do they matter? I don't know if that's correct English, but so I think that it's important to consider all of these because quantitative metrics about the process, how much does it cost? How long does it take? These affect leadership and the customer ultimately, or primarily, I would say. Qualitative metrics around the process are important for the operators, so we aren't pulling our 3 hairs out of our head. And then quantitative metrics around the product are very important to the customer, and qualitative assessments of the product are also important to, I think, the customer and the operators. So how that product is managed and the quality of it. So you can see that the customer or whoever is interacting with the lab really shows up a lot in these metrics. Briefly, it looks like, okay, good. We're halfway there. So next I want to talk about the scope of kind of how I see the scope of the DAMP lab work. We've talked about other things like, trainings and sort of different engagements, but from a perspective of what we're going to do in the lab, I think about sort of the biggest scope is projects, which could be mid to long-term collaborations that might necessitate more technical meetings and planning. Services and bundles kind of go together. These are standardized protocols that are more executable in a repeatable manner. And then I want this to become a thing. This is sort of, I think you can get very granular with how you describe these things, but I see also these sort of microservices as being tasks that people wouldn't really send out to get done, but that sort of locally could be beneficial to labs within BU. And then a little bit more detail on these things. I hinted at this a little bit, but the audience of projects and services might be anybody really, industry, academics, people at BU. But then I see sort of operating in this space of like just one-off small services to people, someone just at the floor up could come down and, have their 4 24-well plates. They hand them off to us and we'll put them in a 96-well plate and give them back a report of what's what and how to keep track of that. Service and bundles, examples of those are like cloning or simple things, DNA extraction and qPCR, things that should be kind of the Taco Bell menu items. Here's a quick snapshot of automation in the DAMP lab. we've mentioned before, we have 40 plus services, talks about, or that number changes with how you define a service, and doesn't really matter too much, but 9 liquid handling robots, 11 automated services, and 22 or roughly liquid handler scripts. These next few slides, I'll just, I think I already acknowledged that there are many automation experts in the room, so I would appreciate more thoughts on this. But the next few things are things that I think about when implementing liquid handling automation, or kind of best practices. And of course, as everything in lab automation, it depends on your end purpose, your end use. But here are some that I think are important. I think it should be accurate and reproducible, flexible, unambiguous, and minimize resource consumption. You might have different criteria if you're in industry, but these are some things that we focused on. Here are some examples of sort of low volume dispenses that were performed with the Hamilton Microlab Star. I was able to achieve less than 15% error with the 1 microliter, and then that gets only better as you increase the volume. These numbers can probably be optimized more than they are, but low volume pipetting is a challenge. And the nice thing you can see is the 1 microliter is consistently wrong. So that's what I was saying about implementing liquid handling. So it's not much variation, but in this particular case, we weren't too concerned with that percent error. So it depends on the process and how much you need it to be optimized. I just noted here that it also depends. I think we talked about this at the standards workshop a little bit. Is sometimes a protocol might say invert a tube 3 to 5 times or something, and you're like, well, how do I automate 3 to 5 times? But I think this is another thing, is that you need to identify critical steps in a protocol. So critical volume steps should be confirmed with quantitative methods, gravimetrically or with fluorescence. And then if it's okay, you're not too concerned with the exact volume, we usually do kind of a semi-quantitative approach. Just check it with a pipette and say, and that's usually pretty good, but it's not exactly as robust as because you're just using your eye and saying, yeah, that looks like the right amount. So we want them to be flexible for end users. Again, this might not be the case for every use case, but I wanted to give people the option of doing different numbers of samples in these methods, which was useful for validating them and testing them, saving time and reagents, and getting them up to speed. And then in some instances, we wanted to sort of define where in the plate those reactions were happening, as well as selecting like different types of labware to be used. So these are all examples of making the methods flexible for end users. The Walter Whites of the world. Actually, no, those were the Homer Simpsons, but it's also important, well, depending on the step, but I think in general, it should be very clear what exactly you want to get done. So protocols should be unambiguous. User dialogues in a method, in a robot, should be clear. And then this wasn't something I was always the best at, but versioning and careful documentation help with troubleshooting and validation. So it's important to keep track of, one day you run this, and then you need to define what indicates a new version should be made, and sort of tracking which versions you're running and what changes were made. This was something that was always on our mind with the pilot projects, and really everything we do. We don't have unlimited funds, so we were thinking about how can we use the resources that we have to the best of our ability. One of the concerns or challenges with automation is sort of getting the right reagents into the right reservoirs to like maximize channel access, but minimize the wasted volume, the dead volume. So this is an example of kind of a decision tree that I came up with here on the right to sort of, and by no means is this like a end all be all, captures every scenario, but it was a way for me to think about and sort of aid users and people thinking about moving a manual process into an automated one to at least get started of thinking, well, do you need 96 channel access, or is it okay with just 8 channel access? And this was done with the Hamilton Microlab Star in mind and some of those labwares that we had. So sometimes there's very specific labwares in a thing like this. And then consider things like reusing tips. This is a big one. Again, depending on the purpose, is this a critical step? Do you need a very, very low variation in this step, or can you get away with tip reuse? So we did a lot of sort of, when it was appropriate, reusing tips was a big thing, or rinsing tips during multiple washes. The last thing I wanted to talk about is next steps. I do have a slide after this with a few things, but before I forget, I wanted to talk about something I envision the DAMP lab contributing in a way that, it's something I've been thinking about for a few weeks, and I've been talking with some folks about it. I think going along with the trend of making lab automation more accessible, and also seems a lot of folks I've talked to say that there are opportunities for better training and education resources. So I see the DAMP lab as sitting in a unique space, being at a university, being interested in lab automation, to sort of think about what sort of curriculum development and training development might be necessary or drive forward the industry and the research that happens in this space. So it's something, now that post IWBMA, I foresee sort of having these conversations aside with people and saying, well, what do you think is lacking in the space of training and education as far as lab automation goes? And I could see sort of a pipeline of students coming through the DAMP lab, learning how to use pieces of equipment, and then sort of going out into the world and spreading the gospel, like Doug said earlier. But aside from that, I think zooming back into sort of like the liquid handling and the next steps that I think we can work on is having more data around these processes, just more instances of runs to sort of validate that they're still working, sort of fine-tuning things as we need to. Better data integration. So I think this is a big one, sort of capturing all the right metadata and sort of cleanly distilling that for analysis and sample or data transfer, and then sort of expanding the number of use cases. So we'd like to continue to increase the number of people we engage with at each of those levels, projects and services and microservices or whatever. And we hope to see some of you and work with some of you in the future. So just acknowledgements. I thank everyone on the team, of course, and especially the leads on all the pilot projects, Kristen and Tig and Molly, Rita. They were the folks that really, were telling me how much lettuce they wanted on the taco, or, sort of telling me what was going wrong with all the methods and gently asking me to fix it. And they were great to work with. So thank you all.